Hello everyone, welcome to the second week of electronics. This week we're going to get a bit more into applying our knowledge of electronics to actually make circuits ourselves and learning the basics of how to actually code microcontrollers to help us control these circuits. Starting off, we're going to go to the website Tinkercad.com, exact same website that was used for the 3D printer training, except this time, once you log in, instead of going on 3D designs, you can go to circuits. Under circuits, go ahead and click on create new circuit. Feel free to pause the video till you make it at this point if you're following along live. Or if you want, when you're done, you can go ahead, come back through and redo it. For the homework assignment this week, it's going to be expected on your website that you have a photo and working circuits of everything that was shown in this video. So all of the test circuits and such, and minor descriptions of how they are and how they're working. And plus more minor descriptions that I'll talk a bit more throughout the video. So, starting off, we're going to pull up a breadboard that I will explain a bit more if that's for those of you that are new into this, and an Arduino Uno. So, starting off with a breadboard is simply a way to connect your different components together. Simply looking, you have each one of these vertical rows gets connected together, and the horizontal rows at the ends are connected like this. They don't connect over the jump. You can highlight and see what's actually connected to one another. Simple enough idea. The negative and positive here doesn't mean they are actually negative and positively charged. It's just for convention to help for labeling's sake. You will want to actually connect this to the negative and positive terminals. Speaking of, what we'll be using as a negative and positive terminal, unlike the batteries that we saw in our examples, is an Arduino. An Arduino is simply a microcontroller that has multiple different pinouts and other various components attached to it. We're not going to go into much depth about actually what the Arduino is internally. That's far more complicated and unnecessary for the time being. So we're going to start off, as I was saying, and we're going to go ahead and connect 5 volt under power to the positive terminal. I'm going to do myself a quick favor and balance this stuff out so it looks clean. And I'm going to go ahead and also set this color to red to have it clear for us. And I'm going to connect the ground as well to the negative terminal. Awesome, there we go. And I'm going to set this to black. Okay, so now we have this side with positively charged, this side negatively charged. We have our positive and our ground. And what we're going to now discuss is LEDs. So, we could connect up an LED. First of all, discussing actually what an LED actually is. LED stands for light emitting diode. And the important word in that is diode. A diode is a component that can only take energy, it can only have the current flow in a singular direction. So, unlike a resistor, where it doesn't matter if the current is going through one way or the other way, a diode will only let the current go through in a single direction. While a light emitting diode is just a type of diode that emits light, and that's why we call it LEDs. The way it works is the current will go from the anode to the cathode. So you're going to connect the positive terminal to the anode as such, and negative terminal to the cathode. We're going to go ahead here and we're going to start simulation. And you can see the LED exploded. That's because we can see the current is too high. So we need to introduce a resistor to limit the current. This is what's known conveniently as a current limiting resistor. Now, the question that you would ask theoretically is, how do I know how strong of a resistor do I need? And unfortunately, there isn't a clear answer in this case. The real answer is when you're working in real life with your component, before you buy your LED, you're going to get you can look up online the data sheet of your product. And that's going to give you the information about the voltage that your LED takes and the current of your LED. With those informations, you could use this equation right here. Resistance will be equal to voltage of the circuit minus voltage of the LED divided by the forward current, divided by the current of the LED. You can plug in those values in here with the voltage of your circuit to then determine the resistance needed to know what resistor you should use. That's not possible here since we don't have a data sheet and have that information. So instead, I'm going to pick the arbitrary value. Oh, gotta delete that green wire there. I'm gonna plug this in, and I'm going to select the arbitrary, and by arbitrary I mean pre-tested value of 400 ohms. Rerun the simulation, and now we have a regular working LED. So the next thing we're going to learn is how to use a button. We're going to use the push button right here. A push button works simply by connecting the first terminal and the second terminal together, while the so it will connect the first terminal to the second terminal, and terminals with the same number are already connected together. So for example, right here, terminal 1A is already connected to terminal 1B, terminal 2A is already connected to terminal 2B. By pressing the button, all you do is connect the four together. So what we can do here is we can combine this with an LED. We can go ahead, we're going to put ourselves an LED up here. We're going to go from terminal 1A, connect that over to, hold on, if we're going to put our cathode there, what we're going to want to do is, yep, that can work. We're going to connect this to ground. We're going to connect this other end of the LED, the anode, to positive. And immediately, you should see the problem with this circuit. If you didn't, well, I'll start simulation and show you once again. LED explodes. We don't have a resistor. Well, solve that quickly. Take that out. Put this in. Set its resistance to 400. And there's our current limiting resistor. Go ahead, start simulation. And that's a button, nice and easy. Not much to it, very convenient. And we're going to learn one more third thing before we actually get more in depth about using the Arduino itself. That's going to be the potentiometer. The potentiometer is an overall cool piece of equipment, and what it does conveniently is it will take in a positive voltage or the current, and then it will resist it to a certain degree based off of how much we turn this potentiometer. So essentially, this is acting as a variable resistor is one of the best ways to describe this. Now, the way this works and the way this connects, unfortunately, it's not very well labeled on this website, Tinkercad. They just tell us terminal, wiper, and terminal 2. But the idea is that the wiper represents the output, while terminal 1 and terminal 2 will be the inputs. So we could go ahead and go wiper. I'm going to connect it over here. I will connect the LED to this. This is going to be, remember, the positive. So I'm going to rotate the LED with the R key so that I can go like this. There we go. I'm going to put it right on top so I can still access these wires right here. This is the cathode, the negative. So let me connect it down to the negative end. Then here, this needs to be connected to ground, terminal 2. And the terminal 1 is going to be needed to be connected to the positive end. Let's go ahead and start simulation. Right here, when it's turned this way, no resistance at all. Turn it more and more, turn it off. This should give you an idea of how LEDs work slightly, how the relation isn't actually directly linear, and you're seeing this very plateaued brightness for a long time before it just spikes and breaking. This has to do with the relation between LED voltage and current, which isn't as intuitive as a simple linear relation. And there we go. That covers the basics of the components that we're going to learn about and be using for this project, and for this project and for the remainder of this week. In the next video, I'm going to go over actually how to code the Arduino so we can do a bit more interesting stuff there. Else than that, just a quick reminder, on your website you should have a photo of your working circuit and just a photo of each one of these working more or less. So button working, button wired correctly, potentiometer, maybe doing a couple different states or so, and there you go. That's it. Not too many photos, not that interesting. If you have like 2-3 photos, documenting your process should be more than enough. And that's about it. There we go. See you in the next video.